Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today I will be solving the problem single element in a sorted array. So the problem statement says that you are given a sorted array consisting of only integers where every element appears exactly twice except for one element which appears exactly once, and we have to return the single element that appears only once. And here it is written that our solution must be in big O of log n time and big O of one space. So the brute force approach which can come into my mind is that we can simply XOR the whole array, all the elements from the starting to the end, and the result of that XOR, after XORing all the elements, the result which we will get, that will be our answer, because the same elements, we know when we XOR two elements, the same elements get cancelled. I mean, they give the answer 0. And here in the array, we can see that only one unique element is there. All other elements are appearing twice. So all the elements which are appearing twice, they will be converted to 0, and the only unique element will be left. Let's say here it is 2. So 2 XOR 0 will give us 2. So we will get the output, but this will take big O of n time complexity. So so the the XORing method will take big O of n time complexity, because we are XORing the whole array. But here it is written that we have to provide solution in big O of log n time. So how we can do this? So let's take an example. I am taking the example 1 only. So here we are given the array 1 1. Here we are given the array 1 1 2 double 3 double 4 and double 8. So first of all, log n time complexity they are asking. So it means that we can think of binary search. All right. So how we can apply binary search? What we can do, we can simply we can simply, uh, first of all, where binary search is applied in the sorted array, and here it is given this is a sorted array. All right. So now if we see the indexes of these elements, here this index is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, 7 and 8. All right. So now we can see we have the indexes also. So we can use these indexes as our low and high, and further we can proceed. So let's say if I take low as 0 and high as 8 here, and now what will be my mid? So mid will be 0 plus 8, 8 by 2, that is 4. So now what we can do, we can check every element, every index, and check whether it is our unique element or not. So my mid is 4. So in this case, I am here. I need to check this, that whether this index element, that fourth index element, that is 3, is unique or not. So how I can check it? Whenever I am standing at any mid, how I can check that this array of mid, that is this fourth index element, is unique or not? So obviously that if it is unique, we can see that let's say we are here. What we can do, we can just look for its left element and look for its right element, and whenever we find that the left and right both elements are different, we can see that we are our mid is only the correct index. But here I can see that left element and right element both are, uh, here I can see that left element is same, and right element is different. So both left and right are not different from this midth element, from this 3. So I can say that this is not my unique element. So now, now the question is, where should we move? Should we move towards right side or should we move towards left side? Where we should move to find our answer? So one thing we have to notice here, that in general we know that 2 is our answer. All right. In general, we know that 2 is our answer. All right. 2 is unique element in this array. So in the left, can you observe that the obviously all the elements will be in pair? In the left, all the elements will be in pair. If 2 is my unique element, in the left we can see these 2 ones, and in the right we can see all the elements are present in pairs. So if we try to observe one thing, that this one, what is the parity of this index? So in the left of our answer, we can see that this one is at even index, and the next instance of the element is at odd index. This one is at 0th index and this one is at 1th index. So we can say that the first instance of the element is even and the second instance of the element is odd before our unique element, before our answer. And after our answer on the right side, after our unique element on the right side, we can see that let's take any pair. We can see that, let's say I take check for these 4. So I can see that the first instance is at 5th index, that is odd, and the second instance is at 6th index, that is even. So I can clearly observe that if I have any unique element, if I have any unique unique element, so in the right side, the first instance will be at odd index and the instance will be at even index, and in the left, the first instance the first instance will be at even index and the second instance will be at odd index. So now, where were we? Our question was that we were standing at this 3. This our mid was 4, and we checked already that the left element and the right element both are not different, so it means that it's not our answer. So now our question was how to move, either to left or to right, because we know binary search, how to play with binary search. So now, using these observations, we can now easily, uh, what we say, uh, take decision where to move. So first of all, what we can do, we can check what is the parity of this mid. So we can see that mid is what, even. So we know that the parity of this is even, so this is even. So now what we can do, this is even, and now, if this is even, we can simply go and check for the left element or either the right element, whatever we want. So I am here checking the left element, that if it is, two cases will be there. Either either we are standing at left or we are standing at right, because if we are not standing at the unique element, then it's obvious that we would be standing either at the left side or either at the right side. So if we are standing at the left side, it means that our parity was even. So it means that if we are standing at the left side, it means that if I check at the left element, it should be less than the current element, because see, here in the left side we can see that the even index element was our first instance, so the element before this first instance will be different. So either we can check that the left element uh, is different or is less than, but we can see that this array is sorted, so it's obvious that the left element will be lesser. So if we are standing at the left and its parity is even, it means if I check the left element, then it should be less than the current element. So now if I check that the left element, that is this 3, is it less than 3? No, it's not less than 3. So it's not less than 3, it's equal to 3. So it means that we are sure that we are standing at the right. We are sure we are standing at the right, because we can see that in the right, if our element is even indexed, then it is sure that it is the second instance, and the left of this element will be the same. All right, so I hope you understood. So what I was saying, that if we, first of all we will check mid, and first of all we will check that if my mid is only the correct index. So how we can check that? We can just check that the left and the right element, if both are different, it means that our mid is the only correct index and nums of mid is my unique element. And else, if it is not true, then we are sure that either we are standing at the left of the unique element, or either we are standing at the right. So we have to, using the rules of binary search, either we have to move to the left or to the right. So how we will check this? Using these observations, because on the left the first instance is even and the second instance is odd, and vice versa on the right side. So we are sure that if it's not our answer, we are sure that it is present in pair. So it means if it's not our answer, this 3 is not our answer, it means it is in pair. So but just we have to determine that what kind of pair it is. Is it even odd pair or it is odd even pair? So if we are able to determine this, we can just say that either we are at the left or at the right. So just using these rules we can just determine. So here what I can see, that the left element was equal, not less. So it means that we are standing at the right. So it means that we have to move left. So if we have to move left, so what we do if we have to move left? So what we do? We just say that what will be high? High will be mid minus 1. So here now my new high will be mid minus 1, that will be 3. So now my mid will be 0 plus 3, 3, 3 by 2 is 1. So now I will be, now I am at this 1th element. So now I'm at this index. Alright, now I'm here. Now again I have to check for the left element and the right element. So I can see here clearly that my element is 1, current element is 1, and the left and the right element both are not different. All right, so if both are different, uh, so we can see that this is our unique element, but both one of them is same as the current element. So it means that we are not at our unique element, we are not at our resultant answer. So it means that either we are at the left or we are at the right. So again I will check the parity of the mid, that is 1, that is odd. So it means either it is following the rule even odd or odd even. So checking this parity as odd, so I will check for the left element here. You can check for the right element also, just we have to determine whatever uh, rule it is following, even, odd, or odd even. So in the left we can say it is we can see that it is even, and in the left we can see this element is 1, and which is not less, all right, which is equal to it. So we can see that in the if we are at the left, so element will be following the pairs will be following even odd rule. So we are at the odd element. It means that if I check at the left side, it should be equal. So if I am checking at the left side and it is equal, so it means that we are at the left, all right. So now it means that we have to move to the right. So how we move to the right, use according to the binary search, we just say that low will be equal to mid plus 1. So mid was 1 and low will be equal to wait, low will be what now? Low will be equal to mid plus 1. So this will be 2. And now my new mid will be 2 plus 3, that is 5. 5 by 2, that is 3. 5 by 2, according to code rules of C++, uh, mid will be 2 plus 3, 5. 5 by 2 is 2, according to division rules. So mid will be now what? Mid mid is 2. So it means that I'm standing at this element now. So now again I will check in the left side and at the right side. So if I check at the left side, I can see this is different from 2, and on the right side I can again see that this is different from 2. So both the elements are different from 2. It means that our current element is the only unique element present in this sorted array. So it means that mid, this index element, is our answer. So just we can, if we found our answer, that then we can just return nums of mid. We can simply return nums of mid. So this was the whole logic. I hope you understood that simple observation is there, that if we are standing at the unique element, then the left and right, both the elements will be different. And uh, if it's not true, then either we are standing on the left or on the right. And how we can determine we are standing on the left or on the right? Using the simple observation we uh, saw here, that either it will be following the parity rule, even odd, or odd even. All right. So if I just go and implement this, so first of all, I would like to declare the size of the nums array. And now I was using binary search, so low will be my 0 and high will be my n minus 1. And now simply what I can do, that I can simply apply binary search. If low is less than high, I can keep moving. And what I can do now, first of all, we used to find mid. So what was mid? Low plus high minus low by 2. And now we uh, we have three cases. Either we are standing at the at the correct resultant element, unique element, or on the left or on the right. So what I can do, I can just define the cases. Let's say my case 1 is checking for the left element. So case 1 will be uh, if nums of mid minus 1 is less than nums of mid. This means that we are standing, uh, this means that our left element is not equal, or let's say less than. So I can declare bool variable, and simply I can just check that if it is true, then return true, else return false. So I think this is only okay. And now one thing more, we should not go out of bound. So I can just simply say that mid should be greater than equal to, I mean, mid minus 1 should be greater than equal to 0. Alright, and then we will check. Alright, so now and in the, I will make the next case for checking the right element. So for checking the right element, first of all, I will uh, check for the boundary, and then I will check that if nums of mid plus 1, if I will check for the right element. If nums of mid plus 1 is greater than nums of mid, it means that the right element is different. So now, first of all, we are at unique element. So if we are at unique element, so we can simply say that our both case 1 and case 2 will be true, because our both left and right elements will be different. All right, so it means that both elements will be different. So if case 1 and case 2 are true, we can simply say that return nums of mid, because we have to return the single element that appears only once, so we have to return that element. And in the else case, first of all, I will check for the, if we are standing if we are standing at left. So if we are standing at left, so if we are standing at left, so the rule will be, parity will be first instance even and second instance odd. So so we have to check that first of all you have to check for the parity. What is the parity of the mid? So if parity of the mid is, let's say, even, so if parity of this is even, then left element should be different. I'm standing at the left, and if the parity is even, then the left element should be different. All right, so I can simply say that the left element should be different. So it means that case 1 should be true. Case 1 should be true. So this means that we are standing at the left. This proves that we are standing at the left. So if we are standing at the left, it means that we have to move to the right. So my low will be mid plus 1. And if my parity of my mid is even even, I mean it's odd, because we have checked for even. So it means that if it is odd, my parity is odd, then the left element should be what? Should be equal. Should be equal. So case 1 should be, should give us false. All right, should give us false, and we can say that we are at the left. And now I will just simply check for standing at right. So similarly, I can copy this, and I will just make few changes here, that either my mid will be even or odd. So if my mid is even, then the left element should be equal. So if the left element is equal, so case 1 should be what? Case 1 should be false. Case 1 should be false, and here my high will be mid minus 1. because if we are standing at the right, we have to move to the left. And if my mid is odd, it means the left element should be different. It means that case 1 should be true, and then we have to move to the left, and this way we have written our binary search. And at the last, we also have to write the dummy returning thing. So now we are ready to run this code, and let's check if we are able to pass sample test cases or not. And it's running, and let's check. So it's giving some error. Let's see what kind of error it is giving. So uh, uh, in the case 2, it is giving error. Let's check what kind of error it is giving. It is giving my output -1. It means that if while low is less than high, it means when low and high both are equal, we are not at the current element. So if low and high both are equal, so we are leaving that case. So if I just run the sample test cases and check, internet is working, and yes, sample test cases are passed. And now if I submit this and check if we are able to pass all the test cases or not. So we are, I think, good to go. We have not made any mistake, if I am not wrong. Let's check for it. So it's giving some error. So we can see that this is giving output -1 when there is only one element. So for let's check for one element. Let's dry run for one element for this nums. So nums n will be what? N will be, for here, n will be 1, low will be 0, and high will be n-1, that is 0. So while low is less than equal to high, yes, it is true. And now my mid will be low plus high minus low by 2, that is 0. Mid will come 0. Alright, mid will come 0. Case 1, that mid -1 is greater than equal to 0. No. Case 2, mid plus 1 is less than n. So again it will not check these case 1 and case 2. It will not check. Uh, it will return both will be false. Both will give false. So if it will give false, and case 1 and case 2, if we run, because both are false, it will be false, and this will be giving false. And if we are standing at the left, it means that first of all, mid, what is the parity of mid? This will be 0, and this, it means that parity of mid will be even. So it means it is even. So this will be true, and case 1 is what? Case 1 is false, so this will give false. And here also this is even, and case 1 is false, so this will be true. So now my high will be equal to mid -1. It means that high will be equal to -1. So now my high will be equal to -1, and now while low is less than equal to high. No. So it will go out of the loop and it will print -1. So okay, so we have to just check for the edge case, that if there is only one element present. So what we can do, if we are going out of loop, so what we should print here? So if there is only one element, we can see that if there is only one element, this is our only answer. This is our only unique element. So we can simply return nums of 0 if we have unique element, if we have only single element. So if I submit this, and this test case should be passed. So internet is, I think speed is not up to that. So, but I think it should now pass, and we can meanwhile talk about time and space complexity also. But I can see there are errors. So, in this case, what error it is giving? If are we missing any HKs? So, in this case, we can see there are three elements, and output is coming one, and expected is two. Obviously, it will be two. So let's check for it. N is coming three, and n minus one is what? It will be two. While less than equal to I, yes. So now a mid will be what? 0 plus 2, 2 by 2, that is 1, and this is 0, 1 and 2, and now mid we can see that it is coming 1, and case 1, that if my left is greater than equal to 0, yes, it is greater than equal to 0, and so what will be it? Is it less than, is it less than nums of mid? No, so it will be false, and this will give true. Why? Because nums of mid plus 1 is greater than nums of mid. Now if we are at unique element, no, we are not at unique element, because case 1 and case 2 both uh, are not true. So if we are standing on the left, we can see clearly. So it means that what is the parity? Parity is odd of the mid. So parity is odd of the mid. It means that first of all, if case 1 is equals to false, case 1 is equals to false, yes. So case 1 is equals to false. So it means that low will be mid plus 1. So my low will be mid plus 1, and now low will go to 1 plus 1, that is 2. And now we are using if we check for this also, and case 1 is 2 now. So now my low will be 2 and high will be 2. Both are equal, yes. Mid will come 2, alright. And case 1, mid minus 1 is greater than equal to 0, and nums of mid minus 1 is less than nums of mid. So if left element is different, yes, so it is true. Is right element different? False, because it does not exist. And if we are at the unique position, it means that case 1 and case 2, okay, we can see that case 1 and case 2, we can see that we are standing at the unique element, that is 2. But here we can see that for the right, if we are checking at the right, it is saying that uh, it is false, but it should be true. It should be true, because we are at the unique element and it is returning false. So it means that we have to modify these case 1 and case 2, because if we are at the last index, that is mid plus 1 is less than n. So what we can do, that if mid plus 1 is less than n, if we are checking for the right and right does not exist, so we should for that case we should return true. All right, so we can just say that if mid plus 1, let's say it's if it is less than n, Wait, what we can do that if it is greater than n, we can return true, else we can check for the right element. Understood? So now this will be returning true. And similarly here, that if mid minus 1 is less than 0, it means that we are standing at the first element, first index, 0th index I mean. So if we are standing at the leftmost index, it means we don't have to check for the left. We will simply return true here. Else, if if it exists, then we can check. Now in this case, both will be true, and this will give true, and we can simply return true. So now if I submit this, and I hope this should submit now without any problem. Network error is there, but I think it should work now because we have modified our code very well. And time complexity, we all know that we are using while loop, and this while loop is going is traveling n elements. So time complexity will be big of log n, and we are not taking any extra space, so uh, the space complexity will be big of 1. So time complexity is big O of log n, and space complexity is big O of 1.
Now we can see that in our case too, if we are at the last element, so first we should check about the uh, out of boundary case. Then we can say that if we are at the last element, we can just check if mid plus 1 is greater than equal to n. It means that it's our last element, and in that case we have to return true. So we can return true, and else we can just check. So now if I just submit this, and now we have solved this problem successfully. So this was all about this problem. I hope you all are you have understood. Till then, keep learning and keep upgrading yourself. See you in the next video.